Hi guys, welcome to lesson 2-7 where we're going to be proving segment relationships. We're kind of just expanding our comfort zone with proofs with this lesson and the next lesson where we're going to be working with proving angle relationships. So our objectives here are to write some proofs involving segment addition and segment congruence. And one thing that I'm going to just walk through before we do our first examples is a lot of the theorems and definitions that we can use as reasons. Basically, to get real comfortable with proofs, what you want to do is have a huge arsenal of reasons at hand that you can use to justify things. So the more theorems you know, the more you'll be able to make statements and justify them. Some of the things that we kind of learned in chapter 1 that we know are some of our theorems regarding points, lines, and planes. Any 2 points define a line. Through any 3 non-collinear points, you can establish a plane. So this could be used in a proof. A line contains at least 2 points. Okay. A plane contains at least 3 non-collinear points. And if 2 points lie in a plane, this is one that you might use probably more often than some of the others. If 2 points lie in a plane, then the entire line that those points lie on also lie in that plane. And of course, we learned that when 2 lines intersect, they form a point. And when 2 planes intersect, they form a line. Now, what we're going to use more in this lesson are reasons, theorems, definitions, and postulates regarding segments. And the first one is our ruler postulate. And this is just a fancy way of saying, basically the postulate says that the points on any line or segment can be put into one-to-one correspondence with real numbers. So given any 2 points, A and B on the line, if A corresponds to 0, then B corresponds to some positive real number. Another way of saying that is that I can have some segment AB, and I can also find the measure of AB. Okay, it can have some value to it. Okay, so this is segment AB, and I would say AB equals 3. What is the length of segment AB? And this is how we would write it. Think of this as a geometric statement. This is in our realm of geometry, and this is an algebraic statement. This is in our realm of equality. Okay. And segment addition postulate. Now this one you'll probably use the most in this particular lesson. If A, B, and C are collinear, then point B is between A and C, if and only if AB plus BC equals AC. Okay? So you can use this to end up figuring out and proving that perhaps 2 segments are congruent, or something like that, depending on what you're being asked to prove. You'll use this a lot. You can add 2 segments to get a longer segment. If you know the longer segment, you can subtract one of the segments to get the other segment. Okay, that's our segment addition postulate. Remember that one. And then just like we looked at some properties of equality in the last lesson, we have properties of segment congruence that we can work with. The reflexive property of congruence. Segment AB is congruent to segment AB. Okay, and we're going to use this more when we get into triangle proofs, but you will see it a little bit here in this lesson. Our symmetric property of congruence. If segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Okay, and that's just, yeah, you can kind of think of it as a formality when you want to flip it at the end to get your proof to line up with exactly what you were being asked to prove. You might need to use that. And this one's really handy because it can save a step, the transitive property of congruence. As we saw in our last lesson, the very last proof I did, we can use 2 substitutions, or you can use the transitive property once. So the transitive property of congruence applies just like the transitive property of congruence applies just like the transitive property of equality. It looks like this. If segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then I can conclude that segment AB must be congruent to segment EF as well. Okay? So that's a handy one to know. Of these three, that's the one you're probably going to use the most often. And then some other definitions that we should be aware of are our definition of a midpoint. Okay, how might we use this? Well, if I had some line segment A, B, and I told you, if I told you that C was the midpoint of AB, what could you conclude from that? C is the midpoint of AB. Doesn't that mean that AC and CB are congruent? They're going to have the same measure. So I can state that in a proof. But how do I justify it? What reason do I give? That is our definition of a midpoint. If you tell me that C is the midpoint, from that I can conclude that these two segments are congruent, because that is the definition of a midpoint. It lies at the midpoint of a line, creating two congruent segments. Likewise, definition of a bisector. Okay, you might see this could be with an angle. If I had some angle A, B, C, okay, and I told you that ray BD bisected angle ABC, well, you could conclude that these two angles are congruent, and you could state that in your proof. And the reason you would give is that's the definition of a bisector. But don't forget, we also have segment bisectors. If I told you that, for instance, if I told you that segment FG bisected segment AB, right? If I told you that line FG bisects segment AB, you could conclude that that is true. That, call that C. AC must be congruent to CB. The reason is definition of a bisector. Okay, now we also have definition of congruence, particularly definition of congruent segments and definition of congruent angles. When do we use these? How do they apply in our proofs? Well, don't forget, we find it easier to work in the realm of algebra when we have to add and subtract things than we do working in the realm of geometry. So if I told you that segment AC was congruent to segment BD, for instance, I could conclude, therefore, that AC equals BD, going back to our ruler postulate, right? These segments have measures, they have values, and we can do algebra on things that correspond to real numbers. So sometimes I want to convert from a statement of geometry, okay, to a statement of algebra, so that we can do algebraic operations on things. And then, hopefully, what you saw in the last lesson is that's a realm where we're more comfortable, okay? All right, and our definition of congruent angles, likewise. If I told you that angle A was congruent to angle B, one thing you might want to write is that the measure of angle A must equal the measure of angle B. Notice again, we're going from a statement of congruence from geometry to a statement of equality in algebra, so that we can add, subtract, multiply, and divide things. Okay, that's a lot to think about, but I think all of this is in your key concepts. You may want to take some notes on this and build up your arsenal of reasons so that you can get good at proofs and get comfortable with them. Okay, let's try a couple. Okay, here they want us to prove that if segment AB is congruent to segment CD, then segment AC is congruent to segment BD. Okay, so let's go ahead and set this up. We've got some given information. Again, notice that pattern. If hypothesis, then conclusion. If given, then proof. Okay, just in case they don't give you this extra bit. Sometimes they don't give it to you, but they're summarizing it here for you. This is the given information, and that's what we're being asked to prove. So if you're setting up your own proof, you're going to go ahead and write what you're being asked to prove up top. Okay, I'm assuming that it's not already there, and I'm doing this in my notebook. That is my GPS, right? That's my compass. keep your eyes on the prize right there. Okay, so you know where you're going. And then we're going to make 2 columns. We're going to make some statements. And each of these statements has to be justified by reasons. Okay, and we're going to restate the given information. Given information is that segment AB is congruent to segment CD. Okay, our reason, that's given. And now, before you even start your proof, make sure all the given information is marked on your sketch. And make sure you have a sketch in your notebook so you can mark it up. So you're going to draw this, and can we mark all of the given information on the sketch? Because it's going to help tremendously to be able to visualize this as you're working through this proof. Segment AB is congruent to segment CD. I'm going to go ahead and mark that, okay? And now, sometimes I even do this. I'm going to highlight what I'm being asked to prove. Being asked to prove that AC, it's a little hard to show, AC is congruent to BD. Okay? Now that I've marked the given information, I can kind of visualize that this is going to be true. It makes sense. And if I could put it in terms of algebra, I think I could prove it. Okay, so hopefully you'll be comfortable getting this all set up, and then you can pause and think about where you want to go from here. Okay, like I said, I think if we could get this into the realm of algebra, we could add and subtract some things and figure this out. For instance, if I told you that, let's just throw some numbers on it. If I told you BC was 5, and I told you AB was 3, if CD is congruent, then it has to be 3 as well. Now you can probably say, well, of course AC is congruent to BD. Each of them measures 8, right? Okay, we don't actually know what they measure, but based on what you just concluded, we should be able to prove this, okay? So let's go ahead and say that if segment AB is congruent to segment CD, that means AB equals CD. They have the same measure, turning a geometric statement into an algebraic statement using our definition of congruent segments, okay? And I think eventually, if you want to just write definition of congruence, that'll be understood, okay? And now, I could say, basically what we just did with the 3, the 5, and the 3 is we added some stuff together, right? Could I say that AB plus BC equals AC? Okay? And one of the reasons I'm doing that is look back at your compass, right? What you're being asked to prove. You're being asked to prove that segment AC is congruent to segment BD. So coming up with an expression that equals AC could be helpful here, okay? What is my justification for this statement? That was our segment addition postulate, right? Basically, I can add 2 segments to get the longer segment. Okay, now I think we could go ahead and do the same thing and say that BC plus CD equals BD, right? And is that also segment addition postulate? And the reason I went after that is now I have these 2 expressions that represent what we're trying to prove here, okay? Now, where would we go from there? Could I go ahead and substitute something in for CD? If AB equals CD, could I substitute AB in for CD right here? Could I write this as BC plus AB equals BD? What did I do there? I substituted, right? That's a substitution. Just substituted AB in for CD right there. Okay. And if I flip this around, maybe this will look a little more obvious. Can I flip this around? AB plus BC equals BD. Did I just use the symmetric property of equality? Right? I'll just use, right, symmetric property, okay? Does anybody see anything interesting here? See these two expressions? They're exactly the same. If AB plus BC equals AC, and AB plus BC equals BD, could I substitute, if AB plus BC equals AC, could I substitute AC in for AB plus BC right here? I could do that. I'm going to plug that in. I get AC equals BD. Okay, what did I do there? I did a substitution. Again, remember in the last lesson I told you guys use this all the time? And you will continue to use it a lot in geometry. Okay, have we arrived at our destination? We were asked to prove that segment AC is congruent to segment BD. I have that AC equals BD. Is that the same thing? Well, almost. Very close, right? Could I convert back from a statement of equality in our realm of algebra to a statement of congruence in our realm of geometry? Can I say, if AC equals BD, if they have the same measure, then they must be congruent. Segment AC must be congruent to segment BD. That would be our definition of congruent segments again. Okay? And notice what we did is we took some congruent statements and we converted them into algebraic statements using that definition of congruent segments. And then we did some algebra. And then we converted them back because that was what we were asked to prove. Okay, so we're done. Q, E, D. All right, let's try another one. All right, here they want us to prove that AY equals BD, and they give us that AC equals AB, AB equals BX, CY equals XD. Now, hopefully the first thing you notice is these are all statements of equality. Right, so we can add and subtract them straight away. We don't have to convert them from statements of congruence. So this is what we're being asked to prove. Keep your eyes on the prize there. That's our GPS. We are going to make some statements. Okay, and we are going to make some reasons. We're going to have to justify every statement. And what are the first things that we always state? Well, we restate a given. AC equals AB. Good. I've got AB equals BX. And I've got CY equals XD. The reason for all of these statements, they are given. Okay? And then before you jump in and start carving out this proof on your own, make sure all of the given information is marked on the sketch, okay? The fact that AC equals AB tells me that AC is congruent to AB. I can mark that. AC congruent to AB, okay? AB equals BX, that tells me that AB and BX are congruent. I can mark it as such. And they tell me that CY equals XD, so I can conclude that CY is congruent to XD, although it may not be congruent to these other segments that we've already marked. Okay. And then I'm going to grab my highlighter. AY equals BD is what we're being asked to prove. That segment is the same length as that segment. Okay. Well, if you could slap some numbers on there, I think you'd be comfortable with it, with this, right? If this was 10 and that was 5, that would mean this is 10 and that's 5, and they'd both be 15, and obviously they'd be equal, right? So how could we get to that in a proof? Okay. So could we say that, I don't know, AC plus CY equals AY? Okay, and that might be helpful because remember, AY is one of the things we're after. Okay, what did we do here? How do we justify that? This segment plus this segment equals this longer segment. That is segment addition postulate, right? Segment addition postulate. I'll abbreviate a little bit there. Now, likewise, I think BX plus XD equals BD, right? bx plus xd equals bd. Okay, also segment addition postulate. Okay, and they wanted us to prove that ay equals bd. Where could we go from here? Notice we've got these other statements that we were given, and we know that cy equals xd. Okay, if cy equals xd, could I substitute cy in for xd anywhere I need to, right? So could I rewrite this this last statement as bx plus cy equals bd, right? Just using a substitution. Okay, and what I'm trying to do is just get this, get two equations that look identical so that I could conclude that ay equals bd. Okay, we're almost there. I've got bx plus cy equals bd, but I also know that bx equals ab, and I know that ab equals ac. Could I conclude that ac equals bx? What property is that? If AC equals AB and AB equals BX, I can conclude that AC equals BX. It's that transitive property. In this case, it's the transitive property of equality, right? Because we're working in equality. All right. So if AC equals BX, could I substitute AC in for BX anywhere I need to? I can do that. So now I've got AC plus CY equals BD. Okay, and now take a look. Are these two expressions identical? They are. If AC plus CY equals AY, can I substitute AY in for AC plus CY right there? Absolutely, I can substitute AY in for it. I get AY equals BD. What did I do? I substituted. Okay, oh, I did two substitutions. I forgot to justify this statement. That was also a substitution, right? Okay, and does that match what we were asked to prove? Exactly. Okay, so we are done. We can say Q, E, D, and our proof is done. All right, let's try one last problem like this. Okay, here in this problem, they're asking us to prove the following. Given that segment GD is congruent to segment BC is congruent to segment FH, and segment FH is congruent to segment AE, could we prove that segment AE is congruent to segment GD? Okay, and you're going to find that once you set these up and you mark all the given on your sketch, these are a lot easier to digest. Okay, so let's go ahead. This is what we're being asked to prove. We're going to make some statements, and we're going to justify each statement with a reason. Okay, and what are the first statements we always make in our proofs? We restate the given information. Okay, segment GD is congruent to segment BC, given. Segment BC is congruent to segment FH, also given. And segment FH is congruent to segment AE, also given. Okay, and now before we start our proof, can we mark all of the given information? GD is congruent to BC. Segment GD congruent to segment BC, right there. Okay, and segment BC is congruent to segment FH. So BC is congruent to segment FH. Good. And segment FH is congruent to segment AE. Okay. And they're asking us to prove that segment AE is congruent to segment GD. Well, visually, we can already see that this is true, right? Okay, another advantage to marking the given information on the diagram. Have a good sketch and mark it up before you start your first statements on your proof. Okay, so where do we go from here? if GD is congruent to BC and BC is congruent to FH, can we conclude that GD is congruent to FH? I could conclude that segment GD is congruent to segment FH, right? What's that property again? That is our transitive property. Okay, remember our transitive property is if A equals B and B equals C, then A equals C. If GD is congruent to BC and BC is congruent to FH, then GD is congruent to FH. Okay, that's our transitive property. Okay, and could we also conclude that if, where do we want to go with this? If BC is, I want to end up with AE and GD. I've got GD congruent to FH, okay? And if GD is congruent to FH and FH is congruent to AE, can I conclude that GD is congruent to segment AE? Again, I used the transitive property a second time, didn't I? Right? And now, is that what we were being asked to prove? Almost. If segment GD is congruent to segment AE, then segment AE is congruent to segment GD. What is that property we used? That is our symmetric property of congruence. Okay. And does that look exactly like that? It does. We are done our proof. We've arrived at our destination. QED. All right. Thanks, guys. I hope you found this lesson helpful. This is a challenging concept when you first encounter it, doing geometric proofs, but I'm hoping that with a little practice, you guys will pick this up really quickly. Don't forget the really important things to do. State what you're being asked to prove. Set up 2 columns, statements and reasons. Restate the given information. Make sure you make a sketch and mark all the given information on your sketch, and then take a deep breath and look at the problem. Look at what you're being asked to prove and start to come up with your own statements that you can justify that will get you closer to that goal. With a little practice, I think you guys will get the hang of it. Thanks for watching, and I look forward to working on some of these with you guys in class.